So this next video is for quantitative homework number 2. The assignment itself can be found at the end of lecture 7. The instructions are here. Just a quick reminder, you are meant to download 10 years with daily frequency from Yahoo Finance of Apple, Amazon, and McDonald's stock prices, and then arrange it all in a sheet. I showed you in the last video how I bring everything in and everything, so I'm not going to get into that. What I'm just going to show you is I sorted everything when I brought it in from the most recent all the way down to the 10-year-old data. And the most recent 3 years are my outsample that I placed in my outsample tab. We'll get to that later. And the last 7 years are my insample. That's what we're working with now. So just so you can see how the data is arranged. Just a reminder, the daily returns is the most recent day divided by the previous day minus 1. And then you just double click that to drag that down. So basically what we're going to be doing here is we're going to figure out our portfolio returns every day based on our individual returns. And then we're going to get a Sharpe ratio out of that. And we're going to optimize that Sharpe ratio, which will tell us how much to invest in each stock for a total weight of 1. Then based on those weights, we're going to plug them into our out of sample and see how well it performs compared to our in sample. If it performs equal to or better than our in sample, we know that we did a good job building our portfolio or building our strategy. So let's start by finding the individual averages of each of the securities. So let's start with Amazon, very simply average. You should know this function, McDonald's, and Apple, average of daily return of Apple. Notice that it's Amazon, McDonald's, Apple, Amazon, McDonald's, Apple, Amazon, McDonald's, Apple. It's all the same order. That's very important for our calculations in the future. So we've found our individual means. Now we also need to find our covariances, because these two things together will allow us to calculate our variance, and our variance allows us to calculate our Sharpe ratio. So there's a few things to note about covariances. One is that the covariance between two identical things is just their variance. So for instance, the covariance of Amazon and Amazon is just the variance of the Amazon daily returns. So I'm going to calculate each of these just so you could see how they're done. So now we're going to do the covariance, because it's two different securities, between Amazon and McDonald's. So the covariance between Amazon and McDonald's. Again, as long as you know that the function is there, Excel does all the hard work. Now let's do the covariance.s. It's always .s because we're working with the sample of Amazon and Apple. Amazon and Apple. Okay. Now let's do the covariance of McDonald's and Amazon. Okay, the covariance of McDonald's and McDonald's is just the variance of McDonald's, so we can just do that. And the covariance of McDonald's and Apple will be our last one for this row. I know this is a little painstaking, but it's important to see because you definitely want to understand how this works. For the last row, we're going to have the covariance.s of Apple and Amazon. Apple and Amazon. And the covariance.s for Apple and McDonald's. And McDonald's. And lastly, the covariance of Apple and Apple, which is just the variance of Apple. Okay, got all that junk out of the way. So what we have now is the portfolio data, but we don't have portfolio returns yet. The way that we find portfolio returns is by assigning each of these a weight, because we need to decide how much we want to invest in each stock. So the important thing to note here is it doesn't really matter what number weight you give to each one right now. I'm just going to arbitrarily assign them up to 10, up to 1. as long as the sum is equaling all three of these. and it equals 1. It doesn't matter what you assign it because we're going to use the solver to optimize it anyways. But now with these weights, we can calculate our portfolio returns using the sum product. What the sum product does is it essentially will take, here let me just lock this in and I'll explain. So what the sum product does is it takes the daily return of Amazon times our weight in Amazon plus the daily return in McDonald's times our weight in McDonald's plus the daily return in Apple times our weight in Apple. And it gives us the return for each day based on those factors. So if I were to change McDonald's to 0.2 and Amazon to 0.3, you can see that our portfolio returns would change accordingly. So there's two ways to calculate the variance of our portfolio. The first is very simply taking the variance function, which Excel lovingly gives us. And the second way is a bit more complicated, but it is the way that's on the formula sheet. And I'll break it down for you real quick because that's what he does in the homework, just so you can see how it works. So essentially, this formula only shows two assets, but you can just add one of these weight and variance phrases and two of these 2 times weight 1 times weight 2 times covariance phrases for 3 assets. I'll show you what that means. So we're going to take the weight of Amazon and square it times the variance of Amazon. Now where's the variance of Amazon? We know that that's Amazon and Amazon, where they meet, right? Plus the weight of McDonald's, square it, times the variance of McDonald's, that's where they meet in the table, plus the weight of Apple, square it, times where Apple and Apple meet in the table. Great. Now what we're going to do is we need to factor in each of the covariances as well. So it's going to be plus, as you can see here from this formula, plus 2 times, let's start with Amazon McDonald's, the weight of Amazon, times the weight of McDonald's, times the covariance between Amazon and McDonald's, plus 2 times, let's do Amazon and Apple now, the weight of Amazon times the weight of Apple times the covariance of Amazon and Apple, plus 2 times the weight of McDonald's times the weight of Apple times Apple and McDonald's, and we get the exact same number. What a relief. That shows you that you did it right. The portfolio mean is very simply just the average of the portfolio returns, and you get a pretty crappy mean, but it is what it is. And lastly, the Sharpe ratio. Our formula for Sharpe ratio is here. We see that normally it's expected return minus risk-free over the standard deviation, but the risk-free is 0 in this assignment, so it's just the expected return, or the mean, divided by the square root of the variance, because we need the standard deviation, and that gives us a Sharpe ratio. Okay, cool. So now we have everything set up. We can see what's going on, and what we can do is we can optimize this portfolio, the weights in our portfolio, to get the best possible Sharpe ratio. And then we can take that and test it in our out of sample. So let us do that. Let's do some solving. Let's go to the solver, and what we're going to do is we're going to optimize our Sharpe ratio by changing our weights. And, oh, my bad, it was doing the wrong one. Optimize our Sharpe ratio by changing variable cells, these 3. And we want to add a constraint that our total weight needs to be equal to 1. And the reason for that is we're not shorting stocks or borrowing money to invest. We're using just 100% of our money. So we want to optimize our Sharpe ratio by changing our weights and keeping them at 1. Let's solve. And we can see that our Sharpe ratio changed, our weights have all changed, and we kept a total of 1. So now what this is telling us is if we invest, my computer's getting all laggy here, if we invest 22% in Amazon, 41% in McDonald's, and 35% in Apple, we should get really good results from this out-of-sample test. So why don't we go ahead and try that out and see what it gives us. So let's copy these weights, plug them into our out-of-sample, and let's figure out our portfolio returns. So now we know, again, sum product based on, now this is our most recent data as of a couple days ago, and our weights. And of course, you're going to lock your weights in because those aren't going to move as you calculate. And let's go down. And we can calculate the variance of the portfolio. And we can calculate the portfolio mean, just like we did before. And we can calculate our Sharpe ratio, which is just the mean divided by the square root of the variance. And we can see, here I'm just going to copy this in to our in sample. I'll just put it right next to it. So we can see that our variance is much smaller, which is a good thing. Our portfolio mean is not much better, and our Sharpe ratio is much higher. So we actually have a lower mean return, but a better Sharpe ratio. So let me just make sure that I didn't screw up the mean. Oh, the mean, okay. I should have just pasted values only. Okay, so we can actually see that our mean increased. That makes way more sense. Yeah, I didn't paste values only, so the calculations got screwed up. Let me change the let me paste values only of the Sharpe ratio as well. So okay, so we can see that our mean increased and our Sharpe ratio increased, which is fantastic because that means that our strategy is really good, and it's going to give us an even better mean and Sharpe ratio than we expected. So we would definitely want to roll with the strategy. So let's look at his instructions. Create your own spreadsheet, we did. Optimize our strategy in sample, we did. And test our strategy out of sample, we tested it, and we got that we would want to use the strategy of these weights because we got a very good Sharpe ratio compared to what we had, and we got a better mean than what we had.